So the reasons for finding the alternative source of. The first reason is that the quality of Yamuna water is deteriorating day by day. You all know that the water of Yamuna is not good to use of any type of animal. And the second is there is a very huge amount of chlorination is done in the treatment of Yamuna water. And third is the conventional type which is being used in the present time is very much costlier because it requires a huge amount of chemical in it. Now, here's the quality statement of Yamuna water. As you see, the color as per Heisen's ratio, and you see the pH values and COD/POD values is approximately 12 to 11 times more as given by the standards of CPCB. CPCB means Central Pollution Control Board. Now, here are the probable raw sources, raw water sources. First is groundwater source. Second is the water from river Yamuna. Third is water from Chambal, and fourth is water from lower Ganga canal. Groundwater, because as we know that the water level of Agra is very low, so it's not possible. You know the case of Yamuna river water, so it's not also good. You can use the water of Chambal river. Chambal river water is good, but it requires 4 to 5 lifting pumps to lift the water from Chambal to the treatment plant, because the gravity difference, the level difference is there. Chambal is approximately 54 meters down from Agra, so it's the level difference. So it requires a mechanical pumping, which costs costly. So now this is the map showing all 4 sources of raw water. There is the first is Upper Ganga, there is that Lower Ganga canal. Here is from Chambal, and there is the 3 and 4 options which are located near Agra. So we choose the merits. So we choose Upper Ganga canal, and there is the merits of Upper Ganga canal. There is a difference of level difference of approximately 34 meters. 34 meters means the water coming from Lower Ganga canal to Agra is without any type of any lifting, without any type of any pumping. So no requirement of any type of pumping is here. The water is coming only through via due to gravity. Second, as we know that Ganga water is pure at its Ganga river is pure at its origin. So what is coming from the origin? So water required very less amount of chemicals and other filtration media to get filtered. Therefore, this is the most visible and economical among the other 4 options, as I told you earlier. Now here is the comparative statement of Ganga and Yamuna river water qualities. As you see, this is the permissible limit of CPCB, and as you see, the Ganga water is approximately near desired by CPCB. Now here now we come to the next section, is for planning and design section. Now, as I told you earlier, we use Upper Ganga canal. Upper Ganga canal, the one means water we should have to lift from we should take water from Upper Ganga canal to Agra. So we regulate from Palda, which is approximately 130 kilometers away from Agra. So we required lay a canal or lay a pipeline, which is an underground pipeline of approximately 2,500 mm dia, and which comes from there to Agra in WW1 Sikandra. Here is the conceptual layout of the project. As you see, the water from Upper Ganga canal is being lifted and sent to WW1, that is waterworks at Jivni Mandi, and this is the WW2 waterworks at Sikandra. Now my project goes on WW2, and the existing, as you see here, these yellow figures are already being constructed, and these orange are now the new facilities. Now this is the existing water treatment plant which is located in Sikandra. As you see, this whole plant is old traditional one, and work on rapid side filter, which requires approximately 12 to 16 hours to get purified the raw water into purified one. So it requires huge time to purification. Now here are the difference of existing water treatment plant and advanced treatment plant which has been constructed in the Ganga project. This is the old technique. It required large amount of area. Processing time is approximately 12 hours. High use of chemicals. This process is expensive, and pre and post chlorination is required. Mr. Jogen, please, if you concentrate, I will tell you more brief here. Now see, in advanced treatment plant, it is an advanced technology. It requires very less amount of area. Processing time is only of 1 to 3 hours, which I as mentioned as 3 hours. There is no chemical is required. Totally is a biological process, and chlorination is used only for purpose of disinfectant. Now here is the layout of the water treatment plant which is being constructed. As you see the health portion which is already been constructed, and the portion which is this portion. This portion is being constructed in the Ganga project. Now here are the structure which consists in the advanced water treatment plant. There are only three are the main buildings. That is, one is CWR, clear water reservoir, and second is MBBR, moving bed biological reactor, and third is CMF, continuous membrane filtration. This is a new technology. Please take attention. This MBBR works on a biofilm filter, as I told you further. This one. This is the biofilm filter, which form bacteria which sucks the impurities in the present in the water, which been and this bacteria eat the impurities and make the water purified. Now here is the purification stage, how this water get purified. The raw waters come from here, then it goes to the primary settling. The whatever sludge is there is being settled here. After that, the water is going in the MBBR. In MBBR there is a process of aerobic and anaerobic bacteria process is there. This in first and second both are the same, but if there is some impurities there that is cleared in second MBBR, after that the final settling is then. After that this water is treated to CMF. Now CMF, as I told you, continuous membrane filtration. It's a membrane made up of fiber, very fine fiber, which approximately filter 10 micron water and filter up to 10 micron. So it's, the water is, after being treated from CMF, the water is approximately like same as we find in packaged drinking water like aquafina, cleanly. Now the next portion is design portion. In design portion, there are some silent features which have been taken in mind while constructing the project. All structures are made from M22 and 35 grade concrete. All structure in all water structure double seal is provided, and after in every water structure hydro test and tube test is done. 10 to 32 mm dia bars have been used in the construction, and the ISO 9000 satisfied guidelines are being executed during the execution. Now the last portion of the section is execution section. Here you see the whole process of this advanced treatment plant. See the raw water comes from this. The water is again sent to the MBBR. Then after MBBR, the water get purified and then sent to the CMF. After closed membrane filtration, the water is directly come to the closed water reservoir. In whole process, whatever the water is wasted is again sent to the waste sludge balancing tank, and after the water is again sent to the inlet mixing chamber. So there is no wastage of water at any cost. So there is, you can say that it's a zero wastage of water. And this the sludge which is being found in this project which used for farmers for their crops as urea. Now here are some live pictures of the project. You see, this is the sludge balancing tank. This is the MBBR. And this is the here aerobic and anaerobic filtration is done. Now my project is over. Presentation is over. Thank you. If you have any queries, you can ask.
What is the anaerobic and aerobic?
Aerobic bacteria are those which are generated and which are born in oxygen, in presence of oxygen. Anaerobic are those which are born and work in absence of oxygen. They are basically in nitrification.
How you maintain the pH value in the water?
So pH value is maintained by using of hypoacid, which is being used in a pre-treatment, as when the water comes in tube settler. There the hypochloric acid is being used, which reduces the pH. And as per the concept of this project, the water of Ganga, the pH is already good. We don't have to change the value of it. So approximately 7, normal water base. Normal base. So you can say that it's what you can say that it's not acidic nor basic. It's on male.
Working process of primary sedimentation.
What you say?
Primary sedimentation tank.
Settling tank, yeah. Same, the water is stored for 10 to 20 minutes in a tank. The primary settlement, whatever the sludge or whatever the mud or anything is in the come during the commissioning from Palra to Agra, this will can settle in the form of sludge. Then that sludge is sent to this.
Screening किसमें होती है?
You don't say the screening कर. Without screening, you.
Sir, what you want to say that now? The screening is not required in this process.
Why?
Because the water is coming in form of inlet. In the raw water is already been screened and pre-settled at Palgra. I have not discussed at that point also. For that you have to go further. As you see the settling tank here, the water gets settled and screened here first. Then what is
You don't say.
तो मैंने बताया.
Screening.
This screening and settling is done at this process only. Because if there is a clear water, what's the need of this screening? This is the whole process. Actually, the main thing is that this is already in function. This has been newly constructed.
What is the size of screen?
Screen you can use. There are many types of screen used in this. Basically, we use approximately 0.5 inch screen.
0.5 inch.
Yeah, 0.5 inch.
How much? 1 inch. How much centimeter?
You can calculate. You are an engineer. You can calculate.
That 0.5 inch is very large.
0.5 inch. Just think how much.
नहीं सही तो है.
With the founder of
3 तरह की होती है.
Gangajal project, nobody is the founder. It's a miracle of civil engineers who do this project, and this is the whole concept based from the thinking on the methodology of Dr. APJ Abdul Kalam, who said about the